So yesterday we completed the number system. We looked at what are the types of numbers, whole numbers,
Yes,
real
sir.
numbers, and all that. Then we looked at operations with numbers,
Yes,
addition,
sir.
subtraction, multiplication, division. And then we looked at rules of divisibility, rules of multiplication. Then we looked at shortcuts for multiplications, division, addition, subtraction, all of that. Okay.
Yes,
Now,
sir.
another very important topic is arithmetic and geometric progression. Okay.
Okay,
Progression
sir.
means what? As it progresses. Okay. How does number systems progress? This is arithmetic and geographic and geometric progression tells us how number systems progress. Okay. So we will look at arithmetic progression first. Look at these two sequences 1, 3, 5, 7, 0, 10, 20, 30, 40. Okay. So 1, number 2 will come in between. Then number 4 is missing. Number 6 is missing. So
Yes,
it
sir.
follows a pattern. Okay.
Yes, sir.
0, 10, 20, 30, 40. So every 10s is being put up in a series. Okay. How are these sequences formed? Each is formed with a first term. Okay. And then to get the successive terms, we just add a fixed value to the previous term. Okay. So 1 plus 2 will give 3. 3 plus 2 will give 5. 5 plus 2 will give 7. A fixed term is being added to every term in the series. Are you getting it?
Yes, sir.
Similarly, 0 plus 10 is 10. 10 plus 10 is 20. 20 plus 10 is 30. 30 plus 10 is 40. So we are adding a fixed term to the series to arrive at the next number in the series. So what will be the next number in this series? 0, 10, 20, 30, 40. What will be the next number?
50.
50. What will be the next number?
60.
60. So how do you arrive at 50 and 60?
20 plus 30 is 50.
No, 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 no. See, how is the series formed? 0 to 10, what is the difference? 10.
10.
10 to 20, what is the difference? 10.
10.
30 minus 20 is 10. 40 minus 30 is 10. What will be the next term?
20.
Add 10 to 40, it will give you 50.
10 to 40.
Did you understand, Kirtana?
No, sir.
You don't get it?
Yes, sir.
Okay, I'll tell you 1 minute. Look at this. What is the... See, arithmetic progression means there is a fixed term which when added to the previous term will give to the next term, will give you the next term. Okay, here look at
Okay.
it. Okay, consider 1. Okay, the first one, first example. 1 plus 2 is 3, right?
Yes, sir.
3 plus 2 is
5.
5. 5 plus 2 is?
7.
Okay, so here you have to add all of these numbers by 2. Okay. Now to
Okay.
get the next term, what will you do?
7 plus 2.
Correct.
9.
So 7 plus 2 is 9.
Okay.
That would be the next term.
Okay, sir.
Do you get it? So a fixed
Yes, sir.
term is getting added
Okay.
to every term to arrive at the next term. Are you getting it?
Yes, sir.
Similarly, consider this examples. These are the next one. 0, 10,
So,
20, 30, 40. What is the fixed term here?
10.
Okay, plus 10. You should always say it is plus 10.
Okay, sir.
Okay, because arithmetic progression can be on negative numbers also.
Okay.
Okay, now this is plus 10. So 0 plus 10 will give you
10.
10. 10 plus 10 will
10
give
plus
you
10, 20.
20.
20
20 plus
plus
10
10,
will give you 30.
30.
30
30
plus
plus
10
10,
will give you
40.
40. And then what will be the next term?
40 plus 10 equal
50.
to 50.
Okay, so The next term will be 50.
50.
This is how you find a term.
Okay, sir.
Okay. Now,
Okay, sir.
a fixed value is being added to every term. Okay.
Okay.
Then it is called an arithmetic progression. Are you getting it?
Yes, sir.
When a fixed term is getting added to every term, it is called an arithmetic progression. A simple logic.
Okay, sir.
Okay.
Okay, sir.
They start with the first term, with a particular first term. They always start with one term. Okay. So here
Okay.
the first term is the first example, the first term is 1. Okay. The second
Okay.
example, the first term is 0. This is the first term. 0 is the first term. Are you getting it?
Oh, yes, sir.
1 in this example, 1 is the first term.
And in second example, 0 is the
0
first
is the
term.
first term. Okay.
Okay.
Then to get the successive term, we just add a fixed value to the previous term. Got it?
Okay. Yes,
To
sir.
get the next term, we add a fixed value to the previous term. In the first sequence, we add 2 to get the next term, and in the second sequence, we are adding 10. Got it?
10. Yes, sir.
Difference between consecutive terms in each sequence is constant. Please note. If the difference between consecutive terms, what is a consecutive term? Next to next.
Okay.
Consecutive. 1 and 3 is consecutive. 5 and
Okay,
7
sir.
is consecutive. 3 and 5
And
is
10 and
consecutive.
20 is consecutive.
10 and 20 is consecutive. Okay. 20 and 30 is consecutive. 0 and 10 is consecutive. Consecutive means next to
Okay, sir.
next. Okay.
Okay, sir.
So if you look at each of the consecutive terms, the difference will be constant. Got it? We can also
Yes, sir.
subtract a constant instead. Okay. So
Okay, sir.
arithmetic progression can be plus or it can be minus also. For
Okay.
example, 852 minus 1 minus 4 here. First term is 8. Okay. What is the
Okay.
difference here? Minus
3.
3.
Minus
Minus
3.
3.
And here also minus 3.
Minus 3. Right?
Yes, sir.
Again minus 3. So everywhere there is a constant difference and the difference is minus 3. Okay. This is also an
Okay,
arithmetic
sir.
progression. Okay, any sequence with constant difference is called an arithmetic progression or AP for short. Got it?
Yes, sir.
Okay. Now we can use a formula to represent an arithmetic progression. Okay. Now, for example, in this is an example that we have shown. Okay. Problems
Okay.
will not be as simple as this. Okay. Problems will be more complicated. Right?
Yes,
So,
sir.
how do we find the difference? For that, we need a formula. Okay. Let A be the first term of the sequence. Have you got it? A is the first term, assuming.
Okay, sir.
Okay. Let D be the common difference, which is the constant difference that we saw will be D.
Okay.
Okay, first term is A. The difference is D. The constant difference is D. Okay.
Okay.
Look at the first sequence. 1, 3, 5, 7, 9 is the first sequence that we saw. Okay.
Mm.
So 1 is 1. Here, what has happened is when we wanted the next term, we just added plus 2 to it. Okay.
Yes, sir.
In the first example we saw. Okay.
Yes, sir.
1 plus 2 gives us 3. Okay. Now,
Okay, sir.
how to arrive at 5? 1 plus 2 into 2. Did you see this?
Yes, sir.
So what we are doing is, we are from A, we are arriving at third term, fourth term, fifth term also, we can arrive at it. See, for example, I will tell you why this is useful is, your questions will not be like 1 plus 2, 3, 3 plus 2, 5. No, not like that. Okay. Your question will have difference of 100 numbers. Okay. They will have a series of 243, 454, 565 and all that. How will you arrive at it? You can't keep adding it, right?
Yes, sir.
That is why for arithmetic progression, we also have formulas which will help us solve the problems much faster. Okay.
Okay.
Now look at this. The next term is 1 plus 3 into 2. 1 plus 4 into 2.
3, 4 into 2.
Okay, now this follows the pattern, right?
Yes, sir.
2 into 1. Actually, here it is 2 into 1. 1 plus 2 into 1. You can also write it like this. 1 plus 2 into 1. So, see, like in this example, you can write 3 is equal to 1 plus 2 into 1. 5 equals to 1 plus 2 into 2. Right?
Yes, sir.
So, the first term is 1. Okay?
Okay.
Second term is 3.
So third term
Third
is
term is
4.
5. 5.
Oh, okay, okay.
Okay. Fourth term
Okay.
is 7. Okay. Now, you look at it. So, this is the first term, second term, third term, fourth term, fifth term. Okay.
Okay, sir.
Now, if you look at it, 2 is constant here. The difference is 2. Okay, given to you already.
Mm. Yes, sir.
That is why we are multiplying by 2. Okay.
Okay.
Now, you look at the third term. Third term is 5.
5.
Okay. Here what we are doing is 2 into 2 we are using. Fourth term, okay, 2 into 3 we are using. Look at this.
Yes, sir.
Fourth term, we are using 2 into 3. Third term, we are using 3 into 2. Fifth term, we are using 4 into 2. 2 is common everywhere. Okay.
Yes, sir.
So, the term will be indicated by n minus 1. Okay. So, how do you arrive at it? N minus 1 into d. What you are doing is actually n minus 1 into d.
Okay, sir.
The nth term. So, now you find the 10th term. Tell me, what is the 10th term here?
17
Right, right. 10th term is 9 into 2 is 18.
and minus 1,
D,
17.
no, it is plus a, no.
Yes, sir.
N minus 1. So 9 into 2 is 18. 18 plus 1 is 19. The 10th term will be 19. How did you arrive at 17? Tell me.
Mm,
N minus 1, right? N is equal to 10.
16. Yes, sir.
N is equal to 10. Okay. So 10 minus
Okay.
1 is what?
10
9.
minus 1, 9.
Yeah. 9. 9 into 2 is how much?
18.
18. Okay.
Yes, sir.
So 18 plus 1 is what? First term is what? 1.
1.
Okay. So that is 19. 9 into 2 equal to 18, ma. Okay.
Okay.
Plus A.
1.
A is
19.
1. That is 19. So similarly, find out the 30th term. I'm giving you a simple calculation. See, why we need
30th
to have a
term.
formula is because of this. You may be asked to find the 100th term. How will you keep adding till 100? You can't add it, no?
Yes, sir.
Like for example, the sequence is given to you in your PO exam. Okay.
Mm.
You will say this is a series, this is an arithmetic progression. What is the 100th term in this series? How will you keep adding for 100 terms?
That's
You can't add
difficult
it,
to
no?
solve. Yes,
So
sir.
you need a formula to solve it. Okay?
Yes, sir.
That formula is a plus n minus 1 into d. Okay? N is what is the term? What is the nth term they want? A is the
59.
first.
30th term is
Sorry?
30th term is 58.
30th term is
Sorry,
what? 58.
59.
Huh? 59. Huh?
59.
1 minute.
Yes,
So
sir.
29 into 2 is 58 plus 1 is 59. Exactly. Correct.
Yes, sir.
Okay. Find the 45th term. Simple, no. 45th
Yes, sir.
term will
Yes,
be
sir.
44 into 2 is 88 plus 1 is 89. Shouldn't take more than 3 seconds for you, Kitna. Simple.
Okay, sir.
89.
89.
Are you getting it?
No, sir.
No. Okay. Now I'm saying find n equal to 45. 45th term. Okay.
Yes, sir. Got it.
Have you got it?
Yes, sir.
So 45 minus 1 is what? 44.
44.
Okay.
And
44,
88
44 into 2 is 88. Plus A is
is
1.
plus 1 is
89.
89.
That's all, no?
Yes, sir.
This is the speed with which you need to come up.
Okay, sir.
Okay. For an arithmetic progression, what is the nth term? The formula is a plus n minus 1 into d. Simple. Okay. Please memorize this. Very,
Okay,
very
sir.
important. Okay. Very
Okay, sir.
important concept. Very important formula. Okay.
Okay, sir.
Now, what would be the last term in case we would, what would be the, sometimes the formula, the problem will be 1, 3, 5, 7 is a series. Okay.
Okay.
Okay. What is the 45th term? They will ask. What is the last term? And the last term will be a plus n minus 1 into d. Okay. That is the formula we are seeing.
Okay.
Find the seventh. In problems, they may not give you the actual series. Okay. For example, consider this example 1. Okay.
Okay.
You have an arithmetic progression with first term 5 and common difference 2. What is the 17th term? Here, the example is not of a series. The series earlier was 1, 3, 5, 7. Then we saw another example 10, 20, 30, 40 and all that. Okay.
Yes, sir.
Here, simple problem, 17th term, arithmetic progression, first term A is 5. Okay. So immediately it should strike you first term equal to A. Common difference is 2. Okay. So
Yes, sir.
17th term they want. So what is the answer? Quickly tell me.
85.
No. A is what? Sorry.
5.
A is 5. Okay. D is what?
2. Sorry, 5. No.
No. D is
2.
2.
2. Yeah, yeah. Sorry, sorry.
Okay. N is what? 17.
17.
So N minus 1 is 16. Okay. 16 into 2 is 32. 32 plus 5
32.
is 37. That's
37.
the answer. Okay.
Okay, sir.
Sometimes the problem may not be a series itself. They will give it to you as a problem. You must be able to
Okay.
identify that the A is
A
this
and D.
value, distance is this, and this is how I need to calculate. Okay.
Okay, sir.
Simple problem. And then let's move on to sum of arithmetic series. Sometimes they will ask you to find what is the sum of this series. Okay, so there will be some 20 terms which will be given in the series. Okay, and they
Okay.
will say you find the sum of the series. And that is given by the formula sum equal to half n into a plus l. Simple, no?
Sorry, sir.
Sum of
Hello.
the series is given by half n, 1 by 2 n into a plus l. That's the formula.
Okay. Okay, sir.
A is the first term, L is the last term, N is the number of terms. That's it.
Okay, sir.
In case common difference is given, see these are variations. Okay. There are
Okay.
problems where they will say first term is this, last term is this, and the total number of terms is n. So find the sum. Okay, they will tell you. But in certain problems, they will not give you the last term. They will only give you the distance. Okay. If the
Okay.
last term is not given, then you should use the distance formula. That is why they have given the distance formula. Okay. Distance
Okay, sir.
formula is half n remains the same, 2a plus n minus 1 into d. Please remember this formula.
2a plus n minus.
No, it is
Okay.
2a plus n minus 1 into d.
Okay, sir.
Similar to the other formula, but 2a instead of a
Okay,
plus
sir.
n minus 1 into d. Okay.
Okay, sir.
If the last term is given, then you should use half n into a plus l. Okay. If the last term is not given, then you should use half n into 2a plus n minus 1 into d. Simple?
Okay,
Okay.
sir.
Remember this formula, you have to memorize this.
Okay, sir.
Okay. Now find the sum of this series. 1 plus 3.5 plus 6 plus 8.5 plus up to 101. Okay. This is the series they have given you. Okay.
Okay.
You have to find the sum of this series. What is a? Here what is a? A is 1, right?
Yes, sir. And last number is 101.
Yeah. So use the formula a equal to 1, L equal to 101.
N, sir.
Huh?
N.
How many terms are in this you're asking? You have to find it.
Okay, sir.
So they have given it. See, you have to find it like this. Okay. 101 equal to a plus n minus 1 into 2.5. Distance you get it, right?
Yes, sir.
What is the distance given here? 2.5 plus 2.5.
0.5. Okay.
Okay. So
Okay.
100 equal to n minus 1 into 2.5. Okay. This formula you just have to use it. Okay. By
Okay, sir.
solving we get 40 equal to n minus 1, n equal to 41. So number of terms here is 41. And then use that formula in the half n into a plus l. Did you get it?
Yes, sir.
What is the answer?
You're asking which answer, sir? N or
The sum is, what is the sum of the series? That's all. The problem, the sum of the series. You have to tell the sum of the series. Sum. What is the sum?
N equal to 41
Hmm.
and S. Mm, mm. 2091, sir.
Exactly, correct. Did you understand?
Yes, sir.
So the problems can be a mix of, okay, somewhere A will be given, last term will be given, distance will be
Okay.
given, number of terms might be given, number of times terms might not be given.
Okay.
Okay, you will be asked to find the total sum.
Okay, sir.
Okay, so this is how the questions will come. Find the first 50 terms of the sequence. Okay. What are,
Okay.
so here it is simple, no, 1, 3, 5, 7, 9, n equal to 50. What is the 50th
Mm.
term? Tell me. 1, 3, 5, 7, 9. A is 1, D is 2, and n is 50. So A plus n minus 1 into D, 49 into
Mm.
2.
In, mm.
98 plus 1 is, oh, here it is the sum, right? Sorry, I'm calculating the last term.
Last,
Last term is what?
they didn't give the last N50.
N is 50.
Yes,
Okay.
sir.
Now, here you have to find the sum for the first 50 terms. What is the formula?
Okay. Mm. Sn equal to 1 by 2 n 2a plus n minus 1
Into D.
into d.
Correct. So using this formula, it is easy to find out. Okay. 2500.
Okay, sir.
Okay.
Okay, sir.
Then next example, you see arithmetic progression has 3 as its first term. The sum of the first 8 terms is twice the sum of the first 5 terms. Find the common difference. Wow. This sum is quite complicated, no?
Yes, sir.
See, sum of the first 5 terms, first 8 terms. Okay. So
Okay.
sum of the first 8 terms is found out using the formula Sn equal to half n into a plus n minus 1 into d. Okay, so you have to use it S8. Okay. First find the
Okay.
S8. So there will be two equations which we get. Correct?
Mm.
See, are you seeing this?
Also,
We are given that a equal to 3.
mm.
Okay.
Okay.
Sum of the first 8 terms is twice the sum of the first 5 terms. Okay.
Okay.
First find the sum of the first 8 terms. S8 equal to half into 8 into 6 plus 7d. Correct?
Mm.
The same formula we are using, yeah. Half n into 2a plus n minus 1
Okay.
into d. Look at the
But how
solution,
the 6
Kirtana.
and 7, uh,
Sorry?
6 and 7 episode வந்துச்சு
6 and
7 எப்படி வந்துச்சு இந்த சம்ல
6 plus 7d. Yeah.
எஸ் சார்
Okay, it is this formula. Just see the formula above. Half n into 2a plus n minus 1 into d. Okay.
ஓகே
This is the sum, the formula for sum. Okay. When last
ஓகே
L is not given. L is not given. So here we have to use D because we have been asked to find the D. Correct? L is
எஸ்
not
சார்
given here. See, if L
எஸ்
is
சார்
given, you have to use the other formula. Okay. If you have L, which formula will you use? Half n into a plus L.
ஸ்லைட்ஸ் வச்சு ஓகே
Sorry?
நத்திங் சார்
See, if L is given, you have to use half n into a plus L to find the sum.
எஸ் சார்
If L is not given, you have to use half n into 2a plus n minus 1 into d. Okay. So in this sum, L is not given, last term is not given, correct?
எஸ் சார்
So you have to use half n into 2a plus n minus 1 into d. You have to find d. D is not given here.
ஓகே
Okay. Now, using this formula, what will be the eighth term? Half into, instead of n, we use 8. Correct?
எஸ்
The
சார்
eighth term is what we have to
எஸ்
find,
சார்
correct?
எஸ் சார்
half into 8 into 2a. What is a here? 3.
3.
So 6. 2a means 6. Okay.
Okay.
N minus 1 is what? 8th term. N is 8 here. Okay. 8 minus 1 is 7. So 70. Got it?
Okay, sir. Okay.
Half into 8 into 6 plus 7d. So fifth term is again similar to that. Half into 5 into 6 plus 4d. Okay. Now it is given that eighth term is twice the fifth term. Sum of 8 terms is twice the sum of 5 terms. So 2s8 s8 equal to 2s5. Are you getting it? That is what it means.
Mm,
Do you understand it, Ketana? S8. The sum
okay.
says S8 equal to
Okay.
twice 2
Mm,
S5.
no, sir. I'm not getting
Read
it.
the sum, no? Arithmetic progression has 3 as its first term. Okay, the first term A is 3. Okay, understood?
Yes, sir.
Sum of the first 8 terms is twice the
Twice.
sum of the first
Okay.
5 terms.
Okay.
If you have to write it down, you have to write it like this. S8 equal to 2S5.
Yes, sir.
Do you get it?
Yes, sir. Yes, sir. Got it now.
Have you got it? So the
Yes,
sum
sir.
of 8 terms is twice the sum of 5 terms.
Okay.
Okay. So
Okay, sir.
S8 equal to 2S5. That is what we are following here. So for S8, we have arrived at half into 8 into 6 plus 7d. Correct? This is
Yes, sir.
S8. So half into 8 into 6 plus 7d equal to 2 into half into 5 into 6 plus 4d.
Okay.
Then we have to solve this equation for d.
Okay, sir.
Have you got it?
Yes, sir.
Okay. So that is why I keep repeating, Ketana, understanding the problem will help you by 50%.
Okay, sir.
Okay, if you understood the problem, you can write it in a way that you can find the solution.
Okay, sir.
Okay?
Okay, sir.
Okay. Now we will move on to geometric progression. Okay. Now consider these sequences 2, 6, 18, 54 and 1, minus 2, 4, minus 8. Okay, what do you see in these
Okay.
sequences?
Mm,
You have to see what is the difference. Okay.
Okay, sir.
2 plus 4 is 6.
Mm,
Okay.
Okay.
6 plus 12 is 18.
It's plus one.
18 plus 36 is 54. Is it right?
Yes, sir.
Okay. Now, what is the definition of an arithmetic progression?
Mm,
In an arithmetic progression, the difference between two terms is constant.
Yes, sir.
Correct?
Yes, sir.
Here, the difference between two terms is varying 4, 12, 36 and all that.
36. Yes, sir.
Okay, now come to the next example. 1 comma minus 2. Here it is minus 3.
Mm,
Okay. Minus 2 to 4. Okay. This is how much? 6 plus 6.
mm,
Okay. 4 to minus
Yes, sir.
8. That is 8. Here again, you see that it varies. The difference between two terms is not constant.
Yes, sir.
Are you getting it?
Yes, sir.
Okay. Now, but how do these terms come? Is there any relationship between these terms? Yes, there is a relationship. What is the relationship?
Mm,
Can you find the relationship between these terms?
No, sir.
You can, yeah. Simple. 2 into 3 is 6.
Mm,
Okay.
Oh, 6.
6 into 3 is 18. 18 into
Okay.
3 is 54.
Okay.
Are you getting it?
Yes, sir.
Right or wrong?
Yes, sir. For another is minus 2,
For another,
right? 1 into minus 2
correct? Then go on.
and minus 2 into 2,
Minus 2
minus
is 4.
2
Minus
and
2
4
into
into
minus 2 is
minus
4.
2.
4 into minus 2 is 8. Simple, right?
Yes, sir. Yes, sir.
So, good, you found out. Okay.
Thank
Now
you.
see this. These are series only. These are series. They are progressing in a particular way. They are progressing in a pattern.
Okay.
Okay. But the difference here is not constant. The difference here is in geometric proportions, which is multiplication or division.
Okay.
Okay, if the terms are progressing in multiples or in divisions, then it is called geometric progressions
Geometry.
or GPs. So here, what is the difference here? It is called a common ratio. It is not a constant. Okay. In
Okay.
arithmetic progression, the difference between two terms is constant. Okay, that constant is called common difference.
Okay.
Okay, the common difference is constant. In a geometric progression, it is
The
called the
ratios
common
are
ratio.
common. Okay, sir.
It will be either multiples or divisions of the previous term. Got it?
Yes, sir.
So here it can be a geometric progression can be expressed as AR square, AR cube. This is the way it progresses.
Okay.
Got it?
Yes, sir.
So the nth term can be found out by A into R power n minus 1. So A plus n minus 1 into D was the arithmetic progression last
Arithmetic
term. The
progression.
nth term will be given by A plus n minus 1 into D in arithmetic progression. Okay. In
Okay, sir.
geometric progression,
A into R
A into
power
R power
n
n minus
minus
1.
1.
R is the common ratio. There D is the common difference because there it's a difference. Here we call it ratio. So instead of D, R is used.
In this example, R is 3 less, sir.
R is into 3, multiplied by 3. You should again say it as multiple of 3, into 3.
Okay,
Okay, because
okay,
there
sir.
can be division also, no?
Yeah, yeah.
See, you will
Okay,
come
sir.
across examples, we will see examples where
Okay.
instead of multiplying, we will keep dividing also.
Okay, sir.
So you have to say
Got it.
the ratio is into 3, multiple of 3.
Into 3.
Correct?
Yes,
So
sir.
you should be correct in identifying that ratio. It can be multiplying or division also.
Okay, sir.
Right?
Yes, sir.
Okay. Now look at this. Look at the first example. Okay.
Okay.
We had A as 2 and R equal to 3. So we could write the first sequence as 2 into 3, 2 into 3 squared, 2 into 3 cube and all that. That is how it progresses. Okay.
Okay,
Second
sir.
example, 1 into minus 2, 1 into minus 2 square, 1 into minus 2 cube. This is how a geometric progression always progresses. A into R power n minus 1. Okay.
Okay, sir.
Simple. How is the sum? So we saw that what is the sum means total. Okay. What is the
Okay, sir.
total for a geometric series? Okay. The sum total for a geometric series is expressed as Sn equal to A into 1 minus R power n divided by 1 minus R, provided that R is not equal to 1. The ratio should not be 1. Okay, it
Okay,
should
sir.
be a ratio. Otherwise, 1 means it is the same. No, 1 minus 1 becomes 0. The denominator will become 0 if it is 1. That is why we should not have the common ratio as 1. Okay.
Okay, sir.
So please memorize this. This is very important. Okay,
Okay, sir.
because there will be a lot of problems on GP.
Okay, sir.
But does it look new or you have studied it earlier?
No, sir. Actually, I skipped that.
You
I skipped this
skipped what?
chapter.
No, yeah, you can't skip it and all. It is 8th standard or 9th standard, whatever. How will you skip a chapter? This comes in your college syllabus?
No, sir.
No, no. Okay, fine.
No.
Okay. Now look at this. Find the sum of the geometric series 2, 6, 18, 54. What is the difference here? 2 into 3, 6.
Same
6 into 3, 18.
into
Same one,
3.
right?
Yeah.
Okay.
Yes, sir.
So there are 6 terms in the series. Where there are 6 terms in the series. N they have given. Okay.
Yes, sir.
The ratio is into 3 multiplied by 3. Okay. So sum equal to a into 1 minus r power n by 1 minus r. So simple.
Yes, sir.
1 minus 3 power 6. 2 into 1 minus 3 power 6 by 1 minus 3, 729 minus 728. So the sum is 728. So here the critical thing is symbols are very important. Okay, in both AP and GP, the plus symbol, minus symbol, these are very important. Okay.
Okay, sir.
Sometimes we will go wrong because our symbol was wrong. Right?
Okay, sir. Yes, sir.
Okay, we'll see another example. How many terms are in the geometric series? 2, 4, 8 up to 128. Nth term is AR power n minus 1. Simple, right?
They're asking how many nth
How
terms.
many terms are there? Okay,
Okay.
AR power n minus 1. What is the nth term given here? 128.
Yes, sir.
Okay, see, always the question will not be find the nth term. Okay,
Mm.
they can give the nth term and they can ask you, okay, which term is this?
Okay, sir.
Like this. So they have given this is the series. First term is 2, last term is 128. Okay, here the L, this is L. Okay, the last
Okay.
term L is 128. Okay, now this
Okay.
L comes in what position they are asking.
Okay.
So 128 equal to 2 into 2 power n minus 1. 2 power n minus 1 is
Another
64.
formula.
Hmm?
It's another formula.
No other formula. This is only one formula for
Okay.
GP. AR
Okay,
power
sir.
n minus 1.
Okay, sir.
Okay, here they have given the term. Okay,
Mm.
they want you to find which term it is. Nth term, which n, what is the n here they want you to find out. You need
Okay.
to use the same formula to find it out.
Okay.
Okay, they have given the term as 128. So, A, what is the first term is A, 2. Okay,
Mm.
2 into, what is the distance here? 2 multiplied by 2. 2 into 2. Okay, 2, 4, 8, 16. That's how this is progressing. Okay.
Yeah,
So
okay, sir.
R is 2, A is 2. So using the formula 128 equal to 2 into 2 power n minus 1.
Okay.
So just solving this you get 2 power n minus 1 is 64. So how do you get 64? 2 square is
2,
4.
2 power
2
6.
cube is 8. 2 power 4 is 16.
16.
Right? Then
Yes, sir.
2 power 5 is 32. 2 power 6 is 64. These all you should know. Okay, simple
Okay,
only.
sir.
Not very complicated. Okay.
Okay, sir.
So 64 can be represented as 2 power 6.
2 power 6.
Okay. So now solving this n minus 1 equal to, so 2 and 2 are common. So n minus 1 equal to 6. So n equal to 6 plus 1 which is 7. So there are 7 terms in the geometric progression. That's all.